Hi, everyone. My name is Seth Wiesman. I am Field CTO here at Materialize. Thank you so much for joining today's webinar. Today, we're going to be talking about real-world context engineering, taking AI agents into production, and the uh, the way in which we help logistics organizations, in particular, be more agile with their data, make better decisions, and streamline their operations. So, one of the things I really love about my role is that I get to spend every day talking to CIOs and CTOs about their most pressing challenges when taking these context problems from the lab into production. And this isn't just going to be a conversation around brokers or data warehouses, your WMS, but the real things that break when you start trying to use data in your day-to-day operations and you start using it with agents, these agents that come online and begin impacting your core mission critical systems that power your operations, your WMS system, your ERP, your Oracle SQL servers and Postgres's, the things that really power your business. So the thing that I hear time and again is that these sorts of operations, these AI agents and other systems, they're not like traditional microservices. They're not like the workloads you traditionally see from your Tableau dashboards, but they're incredibly context hungry. And we'll explain what that means, but that context hunger is breaking a lot of things. So over the next, little bit of time during this webinar, I want to cover a handful of things. So first, what has fundamentally changed in the last 10 years and brought us to this point? We'll have a little retrospective, talk about where context engineering came from and why it's so difficult for teams to get right, especially in scaled organizations that have numerous operational data silos and existing services that depend upon them. We'll talk about some practical steps you can use to bring these services online based on conversations we've had with everyone from startups as well as some of the largest enterprises in the world. And then we'll wrap up with some next steps. So when we want to describe why this is such a hard problem, we can play it out as a uh, play in three acts. First act is our Web 2.0 era. It was the first time you could go to a website, leave, come back, and it would remember something about you, right? So often the applications within your organization, especially ones that you maybe have purchased from a vendor, follow this model. Your warehouse management system, your ERP, there's often an application, it has a database, you leave some data there, you show up later, you can read it again. And for the sorts of services people were building 10, 15 years ago, this worked really well. But then the cloud era came along, and engineering teams suddenly had access to effectively unlimited storage, network, and compute. We saw the emergence of the microservice. You have what we call the two pizza team, creating operational data silos, each with their own database and service. But the biggest change was that a single human action could now fan out to 10 microservice reads and writes across services, queues, caches, and other services. And things started to break at the seams. But as an industry, we adapted. You had MongoDB and Spanner and Cockroach and these scale out databases that could handle this sort of workload. Tools like Apache Kafka began to arrive to help move writes around to various services. And today, we can build these sorts of systems with in a relatively straightforward manner. We know what we are doing. But now we're entering an entirely new era and the agentic era. And there's all this talk about agents coming online. Now, I don't know if anyone has played around with some of those personal agents like OpenClaw, where you can have one idea and suddenly it's not just one agent working on your behalf, it's 10, 30, 50, 100 agents operating simultaneously. And all of them are still running on top of your cloud era infrastructure. So those microservices that you built suddenly need to handle 100x the load. The biggest issue here isn't really the shape of the writes. We know how to scale writes. Agents generate lots of data and we can write it down durably, go back and find it later. The problem is that the read workload is fundamentally different. We're no longer looking for customer 123, but asking for a complete 360-degree representation of a customer and exactly how they're engaging with your brand in that moment. So an agent can make the right decision, whether it's generating an offer, telling you how to move a pallet across a warehouse, or reallocating inventory. And this is fundamentally a different workload, and no existing system was really designed to solve it. So the challenges we see with customers from Fortune 500 enterprises to startups is this. How do you take this siloed operational data, make sure it can handle agent scale rights, and then transform those rights into fresh, trustworthy context, all without your existing databases, ERPs, WMS systems from falling over? It's a hard problem. And it's one of the reasons that while we have these incredible large language models from OpenAI and Anthropic, they still don't really know anything about your business. They don't know your standard operating procedures, and they don't know your customer relationships. They don't know how your business works. And what we need is a way to marry these models with your operational reality. So this is certainly a problem people have been thinking about for quite some time. Last couple of years, we've heard the rise of what we call retrieval augmented generation, or RAG, really came into play, where you could take your large language model and inject specific context, business specific context, excuse me, into the prompt at runtime. And for a demonstration, this works really well. But then you start to realize, like, wait a second, this customer profile is from last year. But I need to know what's happening in my ERP right now. I need to know what's true of my warehouse right this moment, my fleet of trucks, my couriers. If only I had that, I could deliver the experience my customers actually want. So RAG alone is not enough. What we need is really a broader approach. It's how do we gather all the context from across our organization, shape it correctly, deliver it efficiently, and use the right models, all while keeping our system from constantly going offline. This is what we call context engineering. And traditionally, it has been an extremely hard problem. Now, one of the reasons why it is so difficult is that most of the tools in our stack were simply not designed for it. Operational databases have the freshest data, right? Your WMS knows what's true of your warehouse right now. Your ERP can tell you what your customers' information you have, but they're not designed for the complex context reads that agents require. So most organizations start with their data lake, or what some are now calling their context lake. They dump everything into object storage, and you periodically run a batch process over it. And for read only agents, this works really well. But while your data is integrated, it's fundamentally stale. You don't have an up to date representation of your business, your warehouse, your customers, your portfolio, market conditions. So it puts a very low ceiling on what your agents can do. So to ground the path forward and illustrate it a bit, we're going to use an example of a same day retailer, Freshmart. You can think of them as a DoorDash style delivery service, and they have customers and stores and couriers. And it's a very data intensive application. It's built around microservices. They have all these various parts of the business that have a little bit of the picture. But now they want agents and they want to bring them into production. So we're going to follow their journey from pilot into production. The key thing they need to optimize isn't just how quickly an agent can respond to a query, but how quickly real world actions become trusted context an agent can make decisions on. We call this time to trusted action. And when we get it right, it fundamentally changes the experiences we can build. It unlocks what we call the agentic feedback loop. Agents observe the state of your business through operational systems. They think using these powerful large language models, but critically, they don't just make recommendations, they act. They issue refunds, they reroute shipments, they trigger workflows, and then they observe the results of those actions. The feedback loop is key. And to have a feedback loop, we have to be able to observe quickly and trust what we see. Because when an agent takes an action, or even a human takes an action, there's often not one step to reach our final destination. It's incremental steps along the way. And doing that reliably means after each step, observing what happened, deciding if we want to go forward or change direction. So let's look at Freshmart's first generation architecture. They start with a source system like their CRM and ERP, their WMS, all this operational data, and they feed it into an operational data store. Basically, you can think of this as a staging layer where everything is kept up to date. You might use a tool like Kafka to ship your writes around. And then agents can query the system and perform all the work reactively at query time. So when an agent asks for, say, the latest price of an item, we have all the necessary inputs to answer that. But the system has to traverse our entire medallion architecture, the entire set of steps to go from raw data to something semantically meaningful. Figuring out these transforms requires joins, pricing logic, and more, and it's all on demand and at machine scale. And this is incredibly expensive, both in terms of CPU time, but also just dollars and cents. It can cost a lot of money. Realistically, your database administrator, your IT team, is not going to let you run this setup in production, not against your operational database. It's going to take your systems offline almost immediately. So we end up in the situation where our writes are very fast, right? You update something in your ERP, it's available right that moment, but we have slow and expensive reads. Agents can take action, but they can't see the consequences of those actions quickly enough to react intelligently. Our our feedback loop is broken. And Freshmart is going to see this directly, right? It takes 4 or 5 seconds just to assemble one context payload. You can see up to 8 seconds on this graph. That is nowhere near, excuse me, did not mean to do that. That is nowhere near fast enough for a fleet of agents or live production traffic. So what do most teams do? Well, they go to the data lake or the data warehouse. Data is processed through a medallion architecture in batches every hour, every 30 minutes, maybe every 15 minutes, but now it's getting kind of expensive. And these agents are querying pre-computed data instead of our raw system. Now, at first, this looks great, right? Queries are fast, agents are scaling, everybody high fives, like, oh my God, we've done it, we've solved our problem. But of course, this isn't going to be the end of the story. And that's because our customers start to complain. Hey, I ordered something you said was in stock, but then I got a refund. Or, ooh, the price I saw wasn't the price I was charged. Like that's not a good experience. I'm probably not coming back. And the question is what happened? Well, freshness happened. Every second between batch refreshes causes agents to drift further from reality. They start making decisions based on stale context. So maybe, yes, every day at midnight, it's perfectly, it's a perfectly accurate state of the world. But at noon, no, it's 12 hours out of date. At 11 p.m., it's 23 hours out of date. This no longer allows us to see what is true in the moment. And so now we have read-only agents. They can write actions into systems, but they can't observe the consequences of those actions until much later. Now, that might be good enough for a basic text to SQL agent, but not much more. Our feedback loop is still broken. So to go further, we need to fundamentally rethink the data supply chain. And we're going to take inspiration from one of my favorite companies, Chipotle. So Chipotle figured out how to deliver food that is both fast and fresh. They don't cook everything in giant frozen batches. Instead, they continuously bring in raw ingredients, proactively transform them into semi-finished goods, your guacamole, your pico, your rice and protein, based on what they expect customers will need. And then when someone places an order, well, only then do they do final assembly reactively. The insight is that they do an enormous amount of work proactively and only what is absolutely required reactively when something comes to the counter, that everyone gets precisely what they want. And the data world can work in much the same way. What if we continuously integrated our data, continuously staged it, and continually transformed it into live data product, semantic representations of our business, the building blocks that everyone needs? Then, when an agent requests context, well, it only needs to do that last mile work that is unique to what the agent wants. The key innovation here is continuous transformation, and 5 years ago, the science required to do this simply did not exist. But once you have it, everything changes. Fresh Smart's pipeline changes completely. Rights enter the system and propagate through our entire medallion architecture continuously. A price update, a customer event, shipment, or a fleet change is going to become queryable in under a second. And now we have agents that can access rich context without overloading operational systems. And we get the best of both worlds. It's context assembly and extremely fresh data. And that's what enables a tight feedback loop required for these truly powerful agents. So let's see what this looks like in practice. Now, often one of the first things we do when working with a manufacturing or logistics customer is build a live representation of everything happening across their business, from line level operations to plant level aggregations and fleet wide visibility. In this example, we simulate couriers moving around, picking up and delivering orders. And while all this is happening, the system is continuously calculating complex business logic. Understand what is true in this moment. Now, with this, we can have things like dynamic pricing uplifts or revenue at risk from aging inventory or performance metrics. All of this is updated continuously with very strong correctness guarantees. That means what numbers we see right here are true of the world right this moment. We can make decisions off of them. We can walk through one-way doors. Now, once you have this live operational view, the next question becomes, what should I do with it? And that's where agents become transformational. So the Freshmark team can ask, what should I be paying attention to right now? And the agent is going to examine live business context, apply these company specific standard operating procedures, but importantly, marry that with what is true of the world right this moment. What is important right now, not just as of last night. And they can surface the most important issues within seconds. Taking a step further, these agents can rely on this information to proactively make recommendations or even take action on our behalf. So we can follow this up after we take an action and say, what stores need operational support next? Where should we send our teams? And because the agent is grounded in live operational context, because it can observe the consequences of the actions it just took, it can answer immediately and accurately. This creates agents that are highly token efficient because they're not wasting time recomputing massive joins, and it does so without impacting our operational systems. This is what we call context engineering in the real world. Now, you can certainly build this yourself if you have the time and expertise. At Materialize, we're focused on building a platform around these ideas, taking the siloed operational agent scale rights and transforming them into fresh, trustworthy context. We have raised money from some of the world's leading investors and work with some of the world's most forward-looking organizations. Companies like General Mills, who use Materialize to understand what is happening in their manufacturing plants right this moment to make smarter decisions. Crane Worldwide Logistics, who are using Materialize to understand where are shipments in the world, how should their fleets be managed, and Ryder Trucks. Now, all of this is done, importantly, so I went one slide too far, just using SQL, which means that your team and your existing skill set can be productive today without needing to train up on new tools or understand a new way of working. Now, let me go ahead. What we've talked about today is that agents are going to multiply the operational load on our system from 10 to 100x. Their cloud area infrastructure is no longer supporting the sorts of applications your business and customers want. But we can minimize time to trusted action by doing the most important work up front, defining those semantic entities, the nouns of your business, the things that everyone cares about, keeping them always up to date and always correct. And most importantly, these are the sorts of systems that can be rolled out incrementally. We can define just one object, begin using it, build confidence, and have growing wins. So thank you so much for joining this webinar today. If you'd love to see like to see Materialize in action, please scan this code and you can get a little more information. But we have more time during this webinar, so I'm going to pause here and ask if there are any questions I can answer about Materialize, context graphs, or operational systems. I see some folks typing, so I will take another drink of water. So, one of the questions I saw come in are just to talk about the like just better define what these semantic objects are, and for that, yeah, these are often I call them the nouns of your business, the those most important entities. Customer is usually a good one we can anchor on because you are, hopefully your business has customers and you have lots of data about them across any number of systems. So sales has some information, marketing has some other, and what you want is not a representation of what customers did last week, but simply what is true of your customers right now. What is the active email of that customer, their current status within the organization, that true golden record. And these become our semantic objects, the views that we are continuously maintaining. And from that better semantic layer, we can uh, use them as building blocks for us any number of use cases. Another question, is a key feature of Materialize to remove typical ingestion processes for simpler integrations for operational data source? Yes, absolutely. So when we're talking about operational use cases, that often means live data. It means when something changes in your upstream ERP, upstream Postgres database, whatever it may be, I want to see that reflected in less than a second, not every 15 minutes, not every hour. Where a tool like Airflow is really wonderful for your data warehouse. For places where you need periodic updates, you want to periodically pull that data in. Now, the way we do this is going to be very system dependent. I'm going to use Postgres as my running example, but this is going to generalize across any number of systems. Materialize connects directly to that upstream system. So in the case of Postgres, it's via logical replication. It does continuous CDC. So it's getting every change as it occurs in real time. And that means loading is continuous, it is incremental, it does very little work at any given moment. And your data is always live. So it both simplifies your architecture, but more importantly, gives you access to fresher data so that when you ask these questions, you know it's incorporating all the facts of the world. Yeah. So concept of a digital twin. Digital twin is something that I often use interchangeably with semantic object. And so a in the case of logistics or operations, that digital twin may be a digital twin of every shipment, every truck in your fleet, every machine in a warehouse, every operating line. It's taking all the raw data points from across your business. This could be sensors, they could be WMS systems, other services, bring them together and saying, just what is true of this truck right now? And this now becomes a digital twin of your truck that an agent, that a person can look at to say, oh, these shipments are going to be late. A good example from a real use case is you have two trucks going to make shipments to two different stores, and one truck breaks down. Things happen. Well, that truck was going to a store where we have a contract in place that says we're going to have a financial penalty if we don't deliver on time. So the most important action for you to take is actually to reroute the other truck. It's okay if the shipment to store number two is a little late. For you to understand the consequences of that first truck breaking down and how it ripples across your business, we need a digital twin of our trucks and their current status, our orders, our contracts, this live layer of our business. And so now, when one input changes, this truck is broken down, can no longer make its delivery, we can understand the financial impact of that. And it gives us insight into the most important step for us to take. Hope that was clear. Please do not hesitate to follow up if I can be a little clear on that. We'll gonna give it 2 more minutes if there are any other questions. But I do appreciate everyone taking the time today. If please reach out if you have any questions. We have a community Slack. You just want to learn a little more about Materialize, or feel free to connect with me directly on LinkedIn. I'm always happy to chat. Whatever you're working on and to understand if Materialize is an appropriate solution, or generally about context graphs, operational use cases, digital twin. I love to just have these conversations and see what is happening in the world. Okay, I think we will leave it there. Thank you, everyone, again, so much for joining today. The recording will be shared out as we just said in the chat, but it was a pleasure. And I hope everyone has a wonderful rest of their Thursday.